Hi there! In this 3-part tutorial series, you'll learn how to create this anime-inspired ramen scene in Blender. I'll be guiding you through the entire process step by step, and we'll be starting completely from scratch with a new default scene. As I walk in Blender, I'll say which keys I press most of the time. But if I don't, you can still see them displayed in the bottom left corner of the viewport. That way, you should be able to follow along even as a beginner. Though it's best if you already know the basics of how to navigate in the viewport. Now, before we begin, we'll need a reference image for the plate and bowl. I'll create the one for you, which you can get by going to this link here. Or just click the link in the description, which will take you directly to this page. This reference shows the outline shapes of the plate and bowl from side view. And I've also included the chopstick shape here as well, just to make things extra easy for us. So to download it, you can just click here. And then, over here, you will also find the textures I used in my scene. I made all of these myself, so you are free to use them however you like. Now, if you prefer, you could also create your own reference image, or use any side view photo of a plate or bowl. Or you could use a site like dimensions.com to find good references. This site is especially useful since it includes side views showing the inside curves as well. And they even show a 3D model of how it looks. But as I said, I'll be using my own reference, so I'll just go ahead and download this one. And then, back in Blender, I'll start by deleting the default cube by pressing X, while still keeping the camera and light. I can then go into front view by pressing 1 on the numpad. If your keyboard doesn't have a numpad, you can go to Edit, Preferences, Input, and check the Emulate Numpad box. This will make the regular number keys act as the numpad ones. My keyboard has a numpad, so I leave this unchecked. From the front view, you can then press Shift A, go to Image and choose Reference. Then navigate to your reference image and add it to the scene. I can then go over to the Data Properties tab, and here I want to change some of the values. First, I'll scale the image down by setting the size to 0.25. Then, I'll adjust the X offset to -0.128 and the Y offset to -0.025. I will also check the opacity box and set that to 0.25. By doing this, you can now see that these points here are aligned with this red line for the x-axis. And these points here are aligned with the line for the z-axis, which we can see if I quickly go over here to the viewport overlays and check the Z box. Now that we have our reference image here, we can begin to make these objects. I'll start with the plate. And for this, I want to add a single vertex, which I can then extrude along each of these points on this plate shape. But if I press Shift A and go to the mesh options, you can see that by default, there is no option to add a single vertex point. One workaround for this is to add any of these objects, let's say a cube. And then go into edit mode by pressing Tab. And then with all vertices selected, I can press M and merge at center. This will collapse the selected vertices into one single point. But there is actually an add-on that you can enable in the settings that lets you add a single vertex directly without having to go through those steps. So if I exit edit mode again by pressing Tab and then delete this point, I can instead go to Edit and then Preferences. And if you're using an older version of Blender, you can find it in the Add-ons tab by searching for an add-on called Extra Mesh Objects. Though if you're using a newer version of Blender, you will probably find this in the Get Extensions tab. And here, you will need to enable internet access if you haven't already done that. So just allow online access here. If you don't see this box for some reason, you can also go into the System tab and enable it under the Network section. Then just search for extra mesh objects here and make sure it's turned on, and then close the window. And now, if you press Shift A and go to Mesh, you can see that there is now an option called Single Vert. Add that, and then make sure you have Vertex as the select mode, since you won't be able to see it if you are in Face or Edge select mode. I can then press G and then C to move it up along the Z axis, and align it with the first point of the reference image. Next, I want to extrude this vertex over to the next point on this shape. And to do that, I can simply press E and then X to extrude along the X-axis. And then with G and X, I can position it where I want it. Now, to quickly extrude to the next point, you can hold down the Control key. And then if you hover over the point you want to extrude to, and click the right mouse button, while still holding down Control, it will extrude to the point where you have your cursor. And we can then repeat that for the next couple of points. So just hold down Control and right click on each of these points. When it comes to this point here, I want it to be perfectly aligned with the line for the X-axis. So to make sure that it is, I can press N to bring out the sidebar, and then in the Item tab, under the Transform section, we can go to the value for C and put that at 0, which will make sure that this vertex is exactly on the X-axis line here. I will then extrude to the next point using E and X. And then I can continue along the following points using Control and right clicking. When I get to this point here, I can once again press E and then X to extrude along the X-axis. And then using G and X, I can move it closer to the final point. But for this last point, I want it to be perfectly aligned with the first vertex over here. Instead of eyeballing it, we can use Blender's snapping feature here. To do so, I will first press G and then X to constrain the movement along the X-axis. And then if you press B, you can activate snapping. Now just click on the vertex you want to move, then click on the vertex we want to snap to. Now the outline for the plate is done, and I can then exit edit mode by pressing Tab. I'll also hide the reference image for now by pressing H. Then I'll select this object, go over to the modifiers panel and add a screw modifier. And I'll increase the viewport steps to 32. The screw modifier basically takes our flat 2D outline and turns it into a 3D model by rotating it around a 360-degree axis. Make sure to check the merge box as well, so we don't get any overlapping vertices where the ends meet. We can then apply the modifier. Next, I want to make sure that the normals are facing the right direction. To do that, I'll quickly go into edit mode, and then in the viewport overlays panel, I'll check the box for face orientation. You will see that my mesh turns red, and that means that the normals are facing the wrong way. We want to fix this because incorrect normals can mess up things like modifiers or cause shading issues. To fix this, I'll just select everything by pressing A, and then press Shift N to recalculate the normals, and that should solve the issue. The red color will now be on the inside of the object instead, which is correct. I will then go ahead and turn off the face orientation again. And exit edit mode. The resolution could be a bit higher, so to smooth it out, I'll add a subdivision surface modifier and increase the levels to 2. Now the model for the plate is done, and we are ready to move on to the bowl. I'll bring back the reference image by pressing Alt-H, and then hide the plate by selecting it and pressing H. The process for the bowl is the same as it was for the plate, so I'll start by adding a single vertex. Then make sure you are in edit mode and that vertex is the select mode so you can see it. Then using G and C, I'll move the vertex into place on the first point of the bowl in the reference image. I'll then extrude along the X-axis with E and then X, and move it to the next point using G and X. For the next couple of points, I'll hold down Ctrl and right click to quickly extrude. For the flat section, I'll use E and X again, and then continue using Ctrl and right clicking for the following points. For the final point, I'll press E and X once more, and then align it with the first point by pressing G, X, and then B to enable snapping. I'll then click on the vertex I want to move, and then on the one I want to snap to. We can then exit edit mode again, and add a screw modifier. Set the steps to 32, and make sure to check the merge box. We can then apply the modifier. Next, we need to make sure that the normals are facing the right direction. So I'll go into edit mode, enable face orientation in the viewport overlays panel, select everything with A, and press Shift N to recalculate the normals. Then we can turn off the face orientation again and exit edit mode. Finally, add a subdivision surface modifier and set the levels to 2. And now the bowl is done as well. I want the ball to be sitting on the plate, so I'll turn on snapping and set the snap target to face. Then I'll press G and then C to constrain the movement along the Z axis. I'll then simply hover over the top surface of the plate and click to confirm the movement. That should snap the ball right to the top of the plate. Then we can turn off snapping again and switch the target back to increment. Now it's time to make the chopsticks, and these are really easy to make. I'll press Shift A, go to Mesh, and add a cylinder. Right now it's way too big, so I'll scale it down and line it up with the top of the chopstick shape in a reference image. I'll then go into edit mode, switch to edge select mode, and then while holding down Alt, I click the bottom edge loop of the cylinder to select it. Then with G and C, I'll move it down to the bottom of the chopstick shape and use S to scale it down. Next, I'll Alt click the top edge loop and press Ctrl B to add a bevel. You can use the scroll wheel on the mouse to increase the number of segments, so it better matches the rounded shape in the reference. And you can do the same on the bottom as well. I'll then exit edit mode, and with the object selected, I'll right click and choose Shade Smooth. Now, if I bring out the sidebar by pressing N, you can see that the scale values aren't set to 1, and that's because I scaled the object down in object mode. It's usually best to keep the scale at 1, since these values can affect how shaders and modifiers behave. This is especially important if the scale isn't uniform, meaning the values aren't the same on all axes. In my case, all 3 axes have the same value, so the scale is uniform, but I still want to reset it to 1. And to do that, I can press Ctrl A and choose Apply Scale, and that will reset the scale values back to 1, while still keeping the dimensions the same. These values only change when you scale in object mode. If you scale in edit mode, the scale values won't change, so that's just something good to keep in mind. Now I want to add in the table plane, so I'll press Shift A, go to Mesh, and choose Plane. And I'll just keep the default size of 2 meters. Next, it's time to position the camera where we want it. If you press 0 on the numpad, you can go into camera view. You can move the camera the same way as any other object, by selecting it and pressing G. Then with the X, Y, and Z keys, you can move it along those axes. You can also double tap X, Y, or Z to move it along the object's local axis. So for example, if I press G and then C twice, I can move the camera forward or backward along its own orientation. And that works with the X and Y as well. And this is easiest to illustrate if I exit the camera view for a moment. And the camera object is a bit big in the viewport, so I'll scale it down to 0.1. Now, if I for example press G and then C once, you can see that I'm moving it along the global Z-axis. But if I press C twice, it moves in the local Z direction based on the camera's rotation. Another useful thing you can do is you can come over here and change the transform pivot point to 3D cursor. And that way you can rotate the camera around the 3D cursor. And if you hold down Shift and right click, you can move the 3D cursor to where you click. You can also select an object, and if you press Shift S and choose cursor to selected, you can position it on any object you want. To reset the cursor's location, you can press Shift C, which will position it at the center of the scene. But for now, I'll set the pivot point back to medium point, which is the default, and that just rotates the camera around its own center. Another thing you can do is you can go over to the sidebar, and in the view panel, there is this feature called camera to view. And if you turn that on, the camera will follow your scene. So you can move the view around to frame your scene, and the camera will stay locked to it. Then once you're happy with the framing, you can turn it off again. And this is something I use a lot for the cameras in my scenes. Now, I have made this scene before, so I already know where I want my camera to be. So with the camera selected, I'm just going to go over to the item panel. And here, I will just enter the values for the rotation and location that I want to use. You can either enter the same values as I do, or you can position your camera wherever you want. I also want to change the resolution for the camera, so I'll go over to the Output Properties tab, and here I'll set the resolution for Y to 1600. And here, where it says 100%, I'll change that to 200%, so we get double the resolution when rendering. Now it's time to create another copy of the chopstick and position them where we want them. I first go into front view by pressing 1, and from here I can start rotating the chopstick. But right now, it's a bit awkward to rotate, and that's because the origin point of the object is up here. And when the transform pivot is set to medium point, that's what Blender uses as the center of rotation. Now, you could change the transform pivot type to something else, like 3D cursor, and rotate around that instead. But another option is to simply move the origin point itself. So to make it easier to rotate this chopstick, I want the origin point to be at the bottom of the object. To do that, I press slash on the keyboard to isolate the object so we can focus on just it. Then I'll go into edit mode, switch to face select, and select the bottom face of the model. I can then press Shift S and choose cursor to selected to snap the 3D cursor to that face. Then I'll exit edit mode, go to object, set origin, and choose origin to a 3D cursor. Now I press Shift C to reset the 3D cursor to the center of the scene. And you can see that the origin is now placed at the bottom of the object. And with the transform pivot set to medium point, the chopstick will now rotate around that origin, making it much easier for the positioning. From here, you can use R to rotate and G to move it. And you can also go into front, side, or top view to make it easier to position it where you want it. Front view is 1 on the numpad, side view is 3, and top view is 7. If you press G and then Shift C, you'll exclude the Z-axis and move the object only along the X and Y axis. And the same applies with Shift X or Shift Y, depending on which axis you want to exclude. Then, To create a copy of the chopstick, I press Alt-D. Then, using R and T, I can rotate it around the Z-axis to place it where I want. The reason why I'm using Alt-D instead of Shift-D is because Alt-D creates a linked duplicate. Basically, it's just another instance of the same object, while Shift-D creates a completely separate object. And we can see this if I quickly go over to the viewport overlays and turn on statistics. So if you watch this vertex count, you can see that when I use Alt-D, the numbers of vertices in the scene stays the same. And that's because it's still technically the same object. And because this is the same object, that also means that any changes I make to this model will carry over to the other. But if I use Shift-D to duplicate, and then go into edit mode and change something, only that object changes, because it's now a separate copy. And you'll also see that the vertex count goes up, since it's adding more geometry to the scene. So this is basically just a way to save performance. In this simple scene, it doesn't really matter. But in larger scenes, using linked duplicates can really help reduce render times and improve viewport performance. You can then adjust the positions of the chopsticks further if you want. These are the locations and rotations I ended up using, in case you want to use the same. Though, even if you copy my values, it's likely you will still need to do some minor adjustments. So just go ahead and place your chopsticks however you want. And then, once you're happy with your chopstick positions, we are ready to move on to the scene lighting and shadows. To set up the lighting and shadows, I'll first switch to rendered view, so we can see how the lighting looks right now. Then, I'll select the default light in the scene, go over to the data properties tab, and change the type to sun. Right now it's way too bright, so I'll lower the strength, and the value I'll use here is 2.92, which was the value I used last time I made this scene. Next, I'll go over to the render properties tab, and switch the render engine to Eevee, because there's a specific node called shader to RGB, which we'll need later for the materials, and that node only works in Eevee. You'll notice that the shadows don't look great right now. For this kind of scene, we want the shadows to be sharp. So to fix that, I'll go to the shadows section in the render properties and reduce the steps to 1. That helps a bit, but the shadows still look a bit strange. So the next thing I'll do is go back to the lights data properties, and under the shadow section here, we can adjust the resolution limit, and we want to set this limit to a really low value, like 0.0001, and that will give the shadows a much sharper and cleaner look. If you want to adjust the color of the shadows, you can go to the world properties tab and change the world color. The shadow will have whatever color you set here. I'll use the same color I used last time I made this scene, which is this brownish color. But feel free to use any color you like. Finally, with the light still selected, you can go to the item tab in the sidebar and adjust the rotation values to set the direction the light should come from and position the shadows how you want. And here I'll also use the same rotation values I used before, but you can position it however you prefer. Now it's time to start working on the materials for the plate and bowl. To do this, I'll go over to the shading workspace and close the side windows so we have more room to work with. I'll then press 0 to go into camera view and switch to rendered view so we can see how the scene will look with the lighting. I can then select the plate and add a new material to it. I'll just call it plate. Now, before we start working on this material, make sure you have the Node Wrangler add-on enabled. It comes with Blender, but it's turned off by default. So if you haven't enabled it already, just go to Edit, Preferences, Add-ons. Search for Node Wrangler and make sure it's enabled. I'm also going to hide the table plane for now, so we can focus more easily on the plate. Now, there are a few different ways we can create this material. I'll start by showing you the way I did it when I first made this scene, and then I'll show you a few alternative techniques you can try, depending on the style you are going for. First, I'll delete the principled BSDF node. Then, I'll add a glossy BSDF, a shader to RGB, and a color ramp node. Connect the BSDF output to the shader input of the shader to RGB node. Then, connect its color output into the FAC input of the color ramp. Then, to see the result, you can hold Shift and Control and left click on the color ramp, and this will connect it directly to the material output node. Next, I'll set the color ramp interpolation to constant. And that gives us this kind of flat, stylized, black and white shading. If you click on the plus icon, you can add more color stops. And this can also be done by holding down Control and then left clicking anywhere on the color ramp where you want to add a stop. This is where we can define our shadows, midtones and highlights. And if you want, you can pick your colors here directly, but for objects like this, I like to start by defining the shading in grayscale first, and then add the color later. So for example, you could make the middle one be the midtones, and set that color to be something in between the first and last color stop. Then the first stop would be the shadows, and that would be a slightly darker color. Then finally, we have the highlights, which we could give a bright white color. And that way we could get our highlights, midtones and shadows like this on the object. Then over here on the glossy BSDF node, you can play with the roughness value to control how the lights interact with the surface. And here I will just use the same value I used last time I made this scene, which was 0.66. And same goes for the color ramp. So I'll just reuse the values I used before. Now, to add color to this, we can add a mix color node. Set the blending mode to multiply, the factor to 1, and then here you can pick the color you want. This is the color I used for mine. Then to make the color blend in better with the lighting in our scene, we can duplicate the glossy BSDF node and put it in between the mix color and the material output. Also, keep in mind that the look of this shading depends heavily on the scene lighting. If you for example change the sun's rotation, you'll see the shading shift dynamically based on where the light hits. One thing you might notice here is that the highlights look a bit dull right now. And that's because we don't have any bloom effect yet. And to add that, we can use the compositor. So I'm just going to switch this window to the compositor. Then we have to check this use nodes checkbox. And then here we can add any nodes we want to use. And I just want to add a bloom effect. So I'll press Shift A, search for bloom, and just add it in like this. And this will give us the glare node with the type set to bloom. And we can then increase the strength here to something like 10. But right now we don't see the effect, and that's because we have to go over here to the viewport shading options. And down here where it says compositor, we have these 3 options. If you set it to camera, you will see that the effect shows up while we are in the camera view, but it won't show up if we move around in the viewport. Though if we set it to always, the compositor effects will always be visible in the viewport, even when moving around. You can then play with the settings on this glare node if you want. And you could also experiment with the auto glare types, but I'll just keep it at bloom. And the only things I'll be changing here are the strength, which I set to 10, and the quality, which I'll set to high. Then, when you are happy with the effects in the compositor, we can switch back to the shader editor. And there we basically have the base color for the plate done. So what's happening here is that we start with the glossy BSDF node, which gives us the lighting and reflections on the surface. But shader nodes like this can only be connected to other shader inputs, so we can't plug them directly into something like a color ramp. That's why we use the shader to RGB node to convert the shader data into color data, and that lets us feed it into the color ramp and stylize the shading. This only works in Eevee, by the way, since the shader to RGB node isn't supported in cycles. This breaks the normal PBR workflow, but for this kind of stylized look, it works really well. Then with the color ramp, we define our shadows, midtones and highlights. And after that, we use a mix color node to add the color we want our object to have. And finally, we add the glossy BSDF again at the end to help it blend better with the lighting in the scene. If you want to change the shadows, midtones or highlight intensity, you can do that here on the color ramp. But I'll just keep the values I had before. For now, we can also give the bowl the same material. It's going to get its own material later once we add the pattern, but for now, we can just reuse the plate material. One thing you might notice though, is that the plate and bowl colors kind of blend together in the area where the shadow falls. If you want to avoid that, you can add an ambient occlusion node to bring in some shadow information. Then add a mix color node and put in between here. Then I'll take this output and plug into the B input. Set the blend mode to multiply and use the factor slider to control how much of that shadow you want to mix into the base color. I'm just going to set mine at 1. Another thing you can do is add more lights to the scene to get additional highlights on the objects. So for example, you can add an area light, and I'll scale it down to 0.118, which is the value I used before. You can then place it wherever you want, and if you grab this yellow dot on the light, you can point it toward the object. Then, over in the light data properties, you can reduce the power. In this case, I'll set it to 0.15. And as you can see, this adds some highlights on this side of the plate as well, if that's something you want. These are the locations and rotations I ended up using, in case you want to use the same. If you want, you can also give the highlight a slightly different color, which you can do by just changing the light color. And this is the color I'm using. One thing you might notice after adding this light is that it changes the look of the shadow here. And if you want to avoid that, you can simply turn off shadows for this light. Now, like I said earlier, there are other ways you can construct your material to get different kinds of looks. For example, if you want the color to look more matte instead of this glossy one I made here, you can swap out the glossy BSDF at the end and use a diffuse BSDF instead. And that gives you this diffuse result instead, which could work better with certain colors. Another option is to start with a diffuse node and use the color ramp just to define the shadows and midtones. And then you can add the highlights separately, for example by using a glossy BSDF. And in that case, you make the color ramp for the glossy node just black and white and use that as a mask. Then to combine them, you take a mix color node, use the highlight mask for the factor and plug your base color into A. And then in the B input, you can set the color you want for the highlights. And for this, you can just copy the color you used for the base and brighten it up by increasing the value. Then, at the end, you can use a diffuse BSDF again. But personally, I like the original way I set up my material, so I just go back to that version. Now that the base for the material is done, I want to also add a pattern to this. And there are different ways we can do this. And I will show you two different options here. Personally, I like option 2 the most, and I'll explain why I think so in a moment. But first, let's start with the quickest option. For this option, I will first need to UV unwrap the model. But before doing that, I will just go over here to the modifier properties and apply the subdivision surface modifier for this plate object. After that, I can go over to the UV editing workspace. And here, I will switch to edge select. And while holding down Alt, I will select this edge loop right here. I can then either press U or right-click on my mouse and choose Mark Seam. This gives us a clear separation between the top and bottom of the model. And with the face select mode, you can use L to select the part where you want the pattern to be. I want my pattern to be at the top of the plate, so I will select that part, and then press U and choose Unwrap with minimum stretch. If you want the pattern to be on both parts of the object, you can of course also select the bottom part and unwrap both parts. And if you do that, you can come over here and adjust the margin to give them a small gap in between the two islands. And if you use both parts, it could also be a good idea to select them, then go to UV and pack islands. And that way, it will make the islands use more of the UV space here. But as I said before, I only want my pattern to be at the top, so I can get rid of this bottom part again. Now I can't delete this island, so instead, to get rid of it, I can press Shift S and then choose Selection to Cursor, and that will collapse the whole island into one single point right where the 2D cursor is, and that gets it out of the way. And now I can select this top part and press U and unwrap it again, so that it uses the full UV space. And I will set the margin back to the default value of 0.001. Now that the model is unwrapped, we are ready to add the pattern, and I have already created two circular pattern textures, one for the plate and one for the bowl. And you can get these textures from the same link as the reference image we used before. If you want, you can of course also create your own pattern textures using programs like Photoshop or Illustrator. And if you want to do that, I would recommend that you go to UV and export the UV layout. That way, you can then open this UV layout in the program of your choice and have it as a guide when creating the texture. Now, to add the pattern to the plate, we can go back to the shading workspace and add an image texture. And for this, I will import a texture called Plate Pattern Circular. When adding this texture, we can see how the pattern will be applied to the model. And we'll want to mix this pattern with the base color. So to do that, we can take a mix color node. And since this texture is in a PNG file format with a transparent background, we can take the alpha output and use as a mask by plugging it into the factor. And then we can take the result from the color and plug that into A. And then here we can set the color for the pattern. And I will set mine to black. Then we can take this output and link that to the input of the glossy node. And that's the quick way to do this. Now, if your texture doesn't have a transparent background, but it's black and white, you can instead take the color output and use as the mask. Though if it's not black and white, and it's not a PNG with a transparent background, you can still often use the color output if you first take a color ramp and use in between to make it black and white. And then if your pattern contains some specific colors you want to have, you can link the color output into the input where we set a pattern color. But if it's just going to be one solid color, I would leave it unlinked and instead pick the color I want here. If you want to scale the texture up or down, you could go into the UV editor and scale the UV island. And if you scale it down, you'll also need to set the texture extension to extend so that we don't get a repeating texture. But the way I prefer to scale it is by doing it from the shader nodes, by scaling the texture itself in the shading workspace, instead of changing the scale of the UV island here. One way to do that from here is by selecting the image texture, and then if you press Ctrl T, it will give us the mapping and texture coordinates nodes. And you could then scale the texture here. Now the problem here is that when you adjust the scale, you'll also need to adjust the location to keep it centered, which is a bit annoying. So a better way to do this is to not use the mapping node at all. So I'll delete that, and instead I will add a vector math node set to add. And I will set these values to -0.5. Then I can duplicate this node and set it to scale. And then duplicate the first add node again. And for this one, I'll set the values to 0.5. And now I can adjust the scale here while still keeping the texture centered. If you want, you can also add a vector rotate before or after this scale node. And that will let you rotate it as well, though for this texture that isn't super important. Then when the plate is done, we can unwrap the bowl as well. But first, I will select it and apply its subdivision surface modifier. And then we can go back to the UV editor and unwrap this object. And for this object, I will alt select this edge loop here. Then I'll press U and choose Mark Seam. Then I will switch to Face Select and use L to select the top part. Then press U and unwrap with minimal stretch. After that, we can go back to the shading workspace and create a duplicate of this material, and I'll call it bowl. And then for the texture, I will instead use the one called bowl pattern circular. And then the bowl is done as well. Now the downside of using these textures for the pattern is that we can't really change anything with them, since it's a pre-made texture. So if I wanted to change anything with it, I would have to update the texture itself. But I would prefer to be able to do those kind of adjustments to the pattern directly in Blender. And if we take a look at another option I came up with for adding the pattern, which also uses a circular UV unwrap, you will see here that I get a lot more control. So for example, I can adjust this value here to control how far down the pattern should go. And I can control where the pattern should start. We also have these lines here, and with this setup I can control the thickness of them with this value here. So I could easily adjust them. I also have this value here, which lets me control the size of the pattern itself. And here I also have this value, which lets me control how stretched or squashed the texture should be. Then I can also rotate the texture here. And I can control which part of the pattern I want to show. So this is a much more flexible option. and it involves a few more nodes, but it's pretty easy and fast to set up. Though, if you're happy with the way the pattern looks on your models with the first option, and if you don't care about having this kind of control, and if you aren't interested in learning about this other technique, you can skip ahead to this timestamp here. So, to create that setup I just showed, where we have much more control, I will start by deleting these nodes, but I will keep this part and this as well. Though I will change the texture here, and the texture I will use is this one. And this one does not have a transparent background, but it is black and white. So instead of using the alpha for the factor, I'll instead use the color output. Now, this looks a bit strange right now, because we have this circular unwrap here, but the pattern in this texture has a square layout, which doesn't go well together. So we would either have to change the UV unwrap to have a square or rectangular shape, or we have to change the texture to be circular, to work with our circular UV unwrap, and that's what we will do. And the way we will do that inside Blender is by using some math to create what's referred to as polar coordinates in mathematics. So I'll go back to the shading workspace, and I'll move this part a bit to give us some space to work with. Then I'll press Shift A and add a separate XYZ node. Then we can link these two together. After that, I can press Shift A again, and this time I'll add a math node. And I'll change the operation to arctan2. Then I'll take the X here and link to the first value, and take the Y and link to the second value. Then I'll duplicate this node, but I'll change the operation to divide, and link this to the first value here. And for the second value, we'll set this to pi, and we can do that by just writing pi directly here. Next, I'll press Shift A again and add a combine XYZ node. Then take the X here and link to X, and take the Y and link to Y. After that, I'll add a vector math node and set the operation to length, and then link these together. Then I can duplicate the combine XYZ and plug this one into X and this one into Y. Then we can plug this one into the vector of the image texture. It looks pretty strange right now, and that's because the extension for the texture has to be set to repeat. And now this texture has a circular shape. And we can take a mapping node and put in between here. And then we can adjust the scale here, and I'll set that to 3 for now. And this makes it easy to see here how the texture clearly follows the circular shape of the bowl now. Now we have these lines here, which doesn't look great. So to get rid of them, we can change the interpolation from linear to closest, and that eliminates those lines. Now we need to define where this pattern should appear. To do that, I'll start by adding a math node, and I'll change the operation to less than. Then I'll take the output from this length node and plug that into the first value of this node. And the bottom value will be used to define where the pattern should start. I can then duplicate this node, but I'll change the operation to greater than. Then we can take this output and link to the first value of this node. And this value here will be used to define where the pattern should end. Now we want to combine these together, and the way we can do that is by adding a mix color node. And I'll take this output and use as the factor. Then I'll take this output and plug into the B input. And then for the A input, I'll set that to pure black. Now if you preview this, we can see that we get this white part here. And this is where the pattern will show up. And we can adjust this further if we want by playing with these values here. Now, to actually make the pattern appear here, we can take this node and duplicate it. Then we can take the output here and use for the factor. Then we can take the output from this texture and plug that into the B input. And now this pattern appears in the section we defined. Now we can scale the texture here, but if we put the scale at a number that contains decimals, we'll get a visible seam here. So you'll want to make sure that the numbers used here always is a full number. So we can't use something like 5.7, because that will give us a seam. If you want to be able to adjust this value while making sure it always stays seamless, you can take a math node and set the operation to round, and that will round the value to the nearest integer. Then you can link this into the scale, and this way you can control the scale here, and it will always stay seamless. The issue here though is that we lose the ability to adjust the individual axes, specifically the x-axis, which controls how stretched or squashed the texture should appear. And I would like to still have that kind of control. So to keep that ability, we can add a combine x, y, z node and link the value from the round node into y and z. Then for the x value, we can duplicate the round node and link it to x. Then I'll duplicate it again, but for this one I'll set the operation to add and link this to the value for this round node. Then I press Shift A and add a value node and link this to the first input of this node and also this round node here. Then here we can control the overall scale, and then here we can control the X scale as well if we want. And if you don't want to change this in any way, you can leave this at 0. And I'll set this scale to 3. Now the last thing we have to do here is add the lines, which I want where the pattern ends and where it starts. To create those lines, I first move this down. And then I'll duplicate this less than node. Then I'll duplicate it again, but for this one, I'll change the operation to subtract. After that, I'll link this to the bottom input here, and then take the output from this node and plug it into the first input. Then I'll add a value node and link that to the first input of the subtract node, and also this input here. And this value now controls where the pattern should start. And I'll set this to 0.448. And this bottom value here will be used to control the thickness of the first line, and I'll set that to 0.005. Now we'll do a similar thing with the bottom line, and for that I'll duplicate the greater than node here, and then duplicate it again, but for this one I'll set the operation to add. Then we can link this to the second input, and this one will be linked to the length node. Then I'll add a value node here as well and plug that into this input and also into this one here. And this controls where the pattern should end. And I'll set that to 0.38. And this will be the thickness for the bottom line. And I'll set this one to 0.005 as well. Now I can duplicate this mix color node. And then we want to mix these two together. So I'll take this greater than node and use as the factor. And then I'll take this less than node and plug into the B input. Now we have this stripe here, and then we have this one which is slightly thinner than the other one. Then to actually get the lines, we can take a math node and add that here. And I'll set the operation to subtract. Then I can take this one and plug into the second input, and now we get these lines here. Next, we need to mix this mask together with this one. And to do that, we can just take another mix color node. Then plug this one into A and this one into B. Set the factor to 1 and set the blending mode to screen. And now we get the pattern and the lines combined into one mask. Then here you can control the thickness of the first line. And then here you can control the thickness of the bottom line. If you want them to have the same thickness, you can add another value node and plug that into both of these. And then you can set the thickness here, and this will let you control both at the same time. And I'll set that to 0.005. Now, the only thing left to do here is take the output of this mask here and use that as the factor for this one. We can then take all of this and press Ctrl C to copy it. Then go over to the plate material and paste it with Ctrl V. Then we can take this and plug into the factor here. And we can delete these nodes. And then you can adjust these values here to place the pattern where you want it. One thing to keep in mind now is that since we're using separate materials for these objects now, if you change the color in one place, you will have to change the color for the other material as well if you want them to match. And the same goes for the pattern color. If you want, you can actually control the color for both materials at the same time. And to do that, you can use an RGB node, where you set the color and then plug that into the color input. Then, if you select the RGB node and press Ctrl G, you can create a group with just this RGB node. Then, if you press Tab or click this button here, you can exit the node group. Then here, you can give the group a name, and I'll call it Plate and Bowl Base Color. Then, if you select the other object and go into its material, you can add that same group in here. Link it to the color input, and then if you go inside the group, you can change the color from here, and it will update for both objects at the same time, since they both have this node group. And you can do the same for the pattern color. So just add an RGB node, link it to the color input, press Ctrl G to create a group, exit the group, and give it a name. I will call this one Plate and Bowl Pattern Color. And then just add the same group to the other material as well. And that's all for the plate and bowl materials. Now we are ready to move on to the material for the chopsticks. And to do that, I can select one of them, add a new material to it, and I'll call it chopsticks. And since we used Alt D to create a link duplicate, they should both be using the same material right now. Now to create this material, I'll first delete the principled BSDF node. Then I'll add a noise texture. This noise texture will be used to give a kind of wood-like effect, as you can see here. If your noise texture doesn't look like this, you can get it to look similar by pressing Ctrl T to add the mapping and texture coordinate nodes. And here you could, for example, use the object coordinate. And down here you can adjust the scale values to get a more stretched out look. Then over here on the noise texture, you can also adjust the noise scale to get something that feels more like wood. But in my case, it looked fine without these nodes, so I'll just undo that and delete the extra nodes. If you want, you can adjust the contrast of this nose texture by adding a color ramp and then tweaking the stops. And you can also add more stops if you want. In my case, I used a total of 3 stops, and here are the values I used, if you want to use the same. This just gives a very slight subtle change. It's not super important, but it's something you can do if you want. Now, to add some color to this, we can add a mix color node in between here. Set the blending mode to multiply, the factor to 1, and now we can pick the color we want here. This is the color I used for mine. Next, it's time to make this look a bit more stylized and add some highlights. For this, I'll use a texture coordinate node. And then I'll add a separate XYZ node. I'll be using the reflection output here, so take the reflection and plug that into the vector input. Then I'll add a color ramp and take the X output from the separate XYZ node and plug that into the color ramp. Change the interpolation to constant, and from here you can choose where you want your highlight to appear. And adjust the darkest tone. I'll also add a few more color stops for this material. In my case, I used a total of 5 stops, and here are the values I used for my stops, if you want to use the same. Once that's done, I want to mix this together with the noise pattern for the wood texture. To do that, I can use a mix color node. Plug the first one into A and the second one into B. Then set the blending mode to screen. For the factor, you could set it to 1, but I'll set mine to a lower value because I want the wood pattern to be slightly less visible. In my case, I use 0.250 as the value. Then I can take this and plug it into the A input of this mix node. Then here, on the color ramp, I want this last stop to be the highlight, so I can set this to a higher value. I'll set it to 6. To make the highlights look even better, we can also use a layer weight node together with a color ramp. Then, if you set the color ramp to constant, you can adjust the last stop to get the highlight around the edges of the object. And I'll set this one to 6 as well. Now, to combine these together, we can take another mix color node, plug the first one into A and the second one into B, set the factor to 1 and change the blending mode to screen. Then we use this one here instead. Sometimes when you use a value higher than 1, like we do for the highlights, it can reset the value back to 1. If that happens, just go back and set it to the value you want. In my case, I used 6, so I'll set it back to that. And that's the same value I used over here. And with that, the material for the chopsticks is done. Now I can unhide everything with Alt-H, and since we are done with the reference image, we can get rid of it. I could delete it, but I'll just move it to a hidden collection instead by pressing M and then creating a new collection, and I'll call it hidden. Then, to hide the contents of this collection, I can just go over here and uncheck this checkbox, which will hide everything in it, both in the viewport and in the render. Now I think it's time to give the plane here a material as well, and I want my plane to have a wood material, similar to the chopsticks. So what we can do is reuse the chopstick material as a starting point. To do that, I'll first select the plane, then hold Shift and select one of the chopsticks. Then if I press Ctrl L, I can choose Link Materials. And that will apply the same material to the plane. After that, with the plane selected, I'll go over here and click this button to create a new material, and I'll just call this one plane. For this material, I'll keep most of these nodes, but I'll delete the layer weight part, and this here as well, so we're just left with the parts for the reflection and the noise texture. And for now, we can plug this one into the A input of this mix color node. Right now, the noise texture doesn't really look like wood, so to give it more of a wood-like effect, I can select the noise texture and press Ctrl T. Then, if I adjust the scale for the Y-axis, I can get something that feels more like wood. So something like this. Minus 23.5 seems to work in my case. Then here, you can adjust the color if you want. This is the color I use. And at the end, we can add a diffuse node so that it reacts to the lights in the scene. And we get this shadow here. Now, this part is optional, but I found that keeping the reflection part here can help make the wood look a bit more interesting. But I'll switch the interpolation here from constant to one of these options, let's say cardinal, to get a smoother transition. Then I'll adjust the position and values a bit for these stops. Here are the values I use in case you want to use the same. Now I want to mix this together with the wood pattern, and to do that, we can just duplicate this mix node and have the first one go into A and the second one go into B. Then we can take the result of this and plug that into the A input here, where we set the color. Then over here, you can adjust the factor to choose how visible the wood pattern should be, and I'll lower this a bit. So 0.393 is what I use here. Now, if you don't get a good result by just using the reflection like this, you can try adding a mapping node in between here, and that way you can tweak the reflection further if you want. Another option is to use a gradient texture instead. And if you press Ctrl T, you can use object here, for example. Then you can pick what kind of gradient you want to use. Then on the mapping node, you can adjust the location, rotation and scale, and then plug that into a color ramp. By testing different options here, you might be able to find something that looks good. But in my case, I was happy with the result from just using the reflection, so I'll delete this and go back to that. And now this material is done as well. And next it's time to start filling the bowl with our food items. But I'll leave that for part 2, since this video is quite long already. So thanks for watching, and I'll see you in part 2.